So I know you just saw Dr. Hafner demonstrating the difference in moments of inertia and angular momentum when he's spinning around. So let's talk about mathematically what that looks like. So you've got a problem where you're talking about the skater. We're going to approximate the skater as a cylinder. We're going to say the skater with his arms in is a cylinder, and the skater with his arms out is a cylinder with two rods. Okay? We're given the mass of the skater is 60 kilograms, and the radius when he's got his arms in is 0.110 meters. When he's got his arms out, we decrease the mass because he's got some mass in his arms, okay? And then we've got these rods that are about 0.9 meters. So let's actually do the math and figure out what the difference in the moment of inertia is. We're looking for the moment of inertia before he extends his arms, that's our I1, and we're looking for the moment of inertia after he extends his arms, which is I2. So we know that the moment of inertia for a cylinder is 1/2 mr squared, and the moment of inertia for a rod spinning about the end is 1/3 ml squared. We are making some approximations here, but that's kind of how we do it in physics, right? So to find just the moment of inertia of the skater spinning, we plug in this formula right here, 1/2 the mass of the skater times the radius of the cylinder squared. And we get that his moment of inertia when he's holding his arms in is 0.363 kilogram meters squared. Okay, so now let's compare that to what happens when he holds his arms out and we have these rods. The mass of the rods is very small compared to his total mass. But you'll notice when you put in a moment of inertia of this cylinder with the less mass and 2 times the moment of inertia of the rods, plug in all of these numbers and you get that his moment of inertia changes by a huge factor, right? It's like 60. So that is why when he holds his arms out like that, he slows down, right? Because he's actually spreading his mass out significantly. So we write our solution in the box here. With his arms in, it's 0.363. With his arms out, it's 18.5. Huge difference. So I hope this mathematically explains that concept of what happens when the skater holds his arms out. And I hope that that will help you when you're thinking about and working at problems.